The slide is clear.
Yes, sir, it's
It's
clear.
clear now, sir.
Okay. So now the session will be about the conventional and unconventional petrophysical modeling, which is about the gas shale challenge.
I barely hear you, sir.
The voice is clear.
Kamar da ana koyin. Na ce dai barin duba. Kuma da yaran zuba duba. Kai fa kace fa ana iya sai da. Amma ni ne magana kuma ni na karyata ko? To mu karbi karyata nan ma. Ni dai na kuka magana kuma dai na san ba haka nace ba. Ai ma hakuri ai. Ko dole ya ce ga abin da nace. To magana da gaskiya ba mu karbi wannan karyata da kai ba. Ba ni nace. Ai, haka, aya abin. Bugun nan fa kawai ta kwakwashe. Wanda ne? Wanda kusa aiki. Aka ce sai ta fashe zaka an fara tambayan fasawani ya labarin.
We can't hear you, sir.
The voice is clear. My voice is clear now.
Your voice is not audible enough, sir.
So we can start now.
So we can start.
Okay.
Lala?
Me dog yana wannan daga wannan kuku dan kuku ya kashe ayan kaji sun fa'irin a kace kai abin daga nan wannan gasar wato yan ganin ba ne kaje gidan da gata ba wai kai abin wai kai ban da gata
Ashraf, please close the
Yau. Ya zaɓi fita a gurin mutanen rariya. Duk limfon da aka yi na amma na gida ya samu. Gagai da mai gaishe ka.
will be about conventional and unconventional petrophysical modeling, which is about the gas shale challenge.
ruwan ba wanda ya kai ba
Wannan ai ya zo da wani tsarin shi ne. Shi kawai zai duba maka. Zai duba maka. Jimawan Telegram ɗinka ne. Sai baka. Sai tax haka. Amma ni na akwai wani 3,000 ma wanda za a taɓa kamar 0.1 ton. Ai. Ya san
gaskiya fa ba su duba ne ba
0.1 ton. Kasan wani ya yi mistake. Haka
wani ya staking mai biyan bin nan a Binance masu staking din staking dubu uku ka san a kwana uku ka san wannan document sam $100 $100 ne a nan kudin
Please, can you close your microphones?
dok dubu uku aka samu
Ya samu?
ya samu wato dok dubu uku ya ma samu ya ma samu wai mabiya kwana uku ba mu
Ya ma samu $1,000. Ya ma samu. Ana ma
da masu 0.1
15 billion.
mu da 0.1 ton aka ce gashi 0.1 ton dan baiwa ya kiyasa a bashi guda dubu uku a tax din nan gashi wanda mai $1,000 yanzu kwana uku da kyale samu dubu uku
Ai to amma kuma abin da gane ai ba taba mutum kudin sa ke. Ajiya ce fa kawai za ka. Da 0.1 ton to sai ya zo.
Charges technologies over the shale gas will assess the life cycle.
Ni staking din nan. Saboda kaga in dai ka shiga da wuri ka sa ka su zo su saya su staking a bayan ka. Abin zai daga. Yanzu ka duba farashin BNB din ya daga.
You have the exploration well, appraisal well, development, production, rejuvenation.
amma wannan sun tare da mu da za mu sai
The shale gas assessment life cycle. Exploration, appraisal, development, production, rejuvenation. Those are the shale gas assessed life cycle. Also, for the conventional gas and oil drilling usually involve vertical wells drilled into the reservoir. In contrast, while the unconventional resources require the horizontal drilling, which allows access to larger area within the reservoir. For conventional reservoirs containing gas that can easily flow naturally from the source rock. Shale gas drilling technique, technological drilling and completion related. So those are the variables and the metrics. For the completion variables, we have the time on stream, which is the unit of it, which is months. Completion length and the average stage length, the unit of them are foot. Number of stages, average fracture gradient, which is also the unit of it, which is PCI over foot. Breakdown pressure and the ICIP in PCI. Slurry volume pumped and the clean fluid pumped BBL over stage. Acid pumped gallon over stage. Total propane pumped pound over stage. Average injection rate, which is BBL over minute, and the clean fluid rate pound per minute over stage. Gas rate the same unit. Those are the completion variables. For the production metrics, we have the minimum daily average and the mean daily average and the maximum daily average and also the maximum 30-day. All of them the same unit, which is cubic foot, and the 6 months cumulative production, and also the EUR cubic foot. Scale 30-day cubic foot over foot, maximum 30-day, minimum cubic foot over foot, and the cumulative over time also in minimum cubic foot over months. So those are the production metrics. Drilling, completion, stimulation, propant, and fraction. For the shale drilling evolution, we have the trap versus the shale. The trap, which is geochemical structure affecting the reservoir rock and cap rock of a petroleum system, allowing accumulation of hydrocarbon in the reservoir. For the shale, which is fine-grained classic sedimentary rock, formed from the mud that is mix of flakes of clay minerals and tiny fragments of other minerals, for example, calcite and quartz. So also for the shale reservoir, which is classified as unconventional, because they contain oil and natural gas that were generated in the shell itself because they do not naturally have sufficient permeability to allow the oil and gas to flow at commercial rate. Also for the conventional gas, which is found in sandstone, siltstone, and also limestone, whereas the shale gas is less permeable rock. Shale rock are porous, fine grained sedimentary rock that allows extraction of the oil from within. Fracture simulation from 5,000 to 15,000 below the surface, migrating hydrocarbon pools and permeable reservoir layer, frac, shale organic rich source layer, source layer or the source rock, which is the rocks that contain organic material to create the hydrocarbon, which is subjected to the heat and pressure over time. And the organic rich shale, which is unmetamorphized sedimentary rocks ranging in age from
Sorry, sir, you are a little bit fast.
what?
I said, please, you are a little bit faster.
I can't hear you.
I said, please, you are a little bit faster. You are like you are moving above us, sir, above our piece.
Okay. As I said, for the source rock, which is rocks that contain organic material to create hydrocarbons, which is subjected to the heat and pressure over time. For the organic rich shale, unmetamorphized sedimentary rocks ranging in an age from Cambrian to Tertiary. And we have also the hydrocarbon trap, impermeable sealing layer. As I said, for the trap, which is a geochemical structure affecting the reservoir rock and also the cap rock of a petroleum system, allowing accumulations of hydrocarbon in reservoir, while the shale, which is fine-grained classic sedimentary rock, formed from the mud that is mix of flakes of clay minerals and tiny fragments of other minerals, for example, calcite and quartz. For the horizontal drilling technology, which is the horizontal wells, are used in unconventional reservoir because they provide larger area of contact within the formation. Also, the horizontal drilling, which is a process of drilling a well from the surface to the subsurface location, just above the target oil or gas reservoir, called kickoff point, then deviating the well bore from the vertical plane around a curve to intersect the reservoir at the entry point within near horizontal inclination. There is an important question. There is an important question: is the horizontal drilling or the directional drilling is better? So the answer of this question is that the horizontal drilling is better. Why? Because horizontal drilling exposes more reservoir rock to the well bore, and also it allows oil and gas producer to minimize surface impacts of development. So for that, the horizontal drilling is better than the directional drilling. Fracture simulation shale reservoir,
No.
water bearing formation, fracture barrier. Also for the horizontal drilling technique, which is a drilling method, and also which is a type of a directional drilling technique where an oil or gas well is dug at an angle of at least 80 degrees to a vertical well bore. So how deep is the horizontal drilling? 10,000 feet, so which is approximately 2 miles. For the horizontal drilling, gas shale play reservoirs are much more extensive in horizontal dimensions than in vertical. In an area where lithologic barrier is thin or absent, the horizontal drilling is much more effective than the vertical. So for that, the horizontal drilling is better than the vertical drilling. Multi-wells from a single pad have a cheaper cost, so they are not expensive. So we have the pinnite drilling pattern, which we have other types of the patterns like the square pattern, triangular pattern, diagonal plastic pattern. Also for the single pattern can be drilled in 4 directions offset by 90 degrees, each to cover an area of up to 1,200 acres. In the ongoing effort to save the drilling cost, more advanced horizontal drilling patterns has been also developed. So we have also the Petrophysical shale drilling rig, horizontal drilling pattern, which is the pinnite drainage pattern, main lateral, side lateral. For the fishbone drilling, which is consists of drilling several micro holes in different directions. From the main vertical or deviated well bore. Also, the objective of the fishbone well geometry is also to increase the drainage area of the reservoir by maximizing the reservoir contact within the branches drilled in the fishbone pattern. As a result, the production rate will increase with an optimized drilling and completion cost. So for the fishbone, which is utilize one borehole that is connected to the multiple lateral. This simulation technology can be used in both onshore and offshore wells within poor reservoir characteristics to increase the oil recovery and also the access complex geological formation. Also for the fishbone, which is efficient variant multilateral well design, this method involves drilling different branches within efficient geometry. A design informed by the length of the branches, their spacing, the angle between the branches and the main borehole, and the direction of the branches. What is the main purpose of the fishbone? Which is help in brainstorming or to identify the possible causes of a problem and in sorting ideas into useful categories. It also improves the conformance by spacing the lateral, allowing the entire well bore, helping to improve the conformance along the horizontal section. Technological and engineering issues. Technological simulation and production related. This picture shows the hydrovac operation for the shale gas simulation job. For the reservoir heterogeneity, which is affect the distributions of remaining oil through the flow barrier, distributions, pattern of sedimentary architecture units, permeability, or reservoir pore structure, and other aspects. So also for the heterogeneity, which is a spatial variation in properties, is a features in all naturally occurring permeable media and one of the most important factors for an oil and gas reservoirs. So we have the high resolution heterogeneity is measured via continuous scratching along the length of the core. As this system found in the lab or field system, then the results provide a profile of unconfined strength and its variability along the length of the core. So also for the composite channel unit formed by overlapping and separated the stable channel, or the lateral alternated unit within the braided channel, and sheet flow sediment is affected by the heterogeneous inching of injected water along the large pore throat channel. The remaining oil is formed in patchy distribution, such as the flow around an island, and it also inertiated in the upper part of the composite layer. So this shows the shadows of volatile heterogeneity measurement. For the reservoir anisotropy, which is one in which the porosity and the thickness are the same throughout the system, but the permeability varies within the direction. Also, the reservoir anisotropy, which is the implication of the anisotropy, is that the material properties are different in vertical direction, which is perpendicular to the bedding, and for the horizontal direction, which is parallel to the bedding. And that properties vary strongly within the orientation to bedding. So, for the anisotropic properties can be obtained via laboratory testing using the core scale, and for the 3D seismic using reservoir scale. We have also that the reservoir heterogeneity can be microscopic or macroscopic, meaning that the rock properties vary from the micro to field scale. Anisotropy also can be structure, magnetic, or both. So also it refers the properties of the material or its physical characteristics vary depending on the direction. In the context of the magnetism plays a crucial role in controlling and influenced by the factors such as spin orbit, coupling, and charge distribution around the magnetic atom. So also for the conventional analysis, ignoring the anisotropy, we have to use this law analysis, including transverse isotropy, by using this law analysis, including the full anisotropy, which is a dipping bedding, by using this law. Also for the anisotropy, which is, can affect the physical, mechanical, seismic, thermal, and hydraulic characteristics of these rocks, so that they behave differently in different directions. So what causes the reservoir heterogeneity? Due to the influence of the sedimentary environment, diagnosis, and tectonic processes during the formation process. So these things could cause the reservoir heterogeneity. This is an example found in Texas, calcite, which we have also the 10.1% TOC, which is the total organic carbon. Total organic carbon, which is the amount of organic carbon present in source rock expressed as weight present. 0.55%, which is the oil resistivity. So this refers to the type 2 corrosion. For the free gas and the adsorbed gas, free gas, which is a shell gas in pore space within shell rock, while adsorbed gas is a significant quantity of gas adsorbed on surface of organics and clay in shell formation. Also for the gas shell, which is a form of natural gas found in underground in shell rock, it is classified as unconventional because it is found in shell, which is a less permeable rock formation than sandstone, limestone, or siltstone. Is there is anything is not clear? Guys, is anything is not clear? Could you hear me? Okay, perfect. Also, this shows a standard shell gas well construction. Generalized casing design for Marcellus shell gas, which is a type of the shell gas well. 24 diameter conductor casing, which is 30 to 50 feet, which is freshwater aquifer. The diameter of the casing, which is 20, it will be 200 to 500 feet. Coal bearing interval. 13 3/8 casing up to 1000 feet, which is cemented to the surface for the shallow sandstone and shale, which is the gas and brine. 9 5/8, which is if it's necessary to seal off the shallow oil or gas or brine bearing zones. So the casing for the vertical and horizontal wells identical to this point. For the Marcellus shell, which is 5.5 casing cemented to 500 above Marcellus. So this shows a generalized casing design for Marcellus shell gas well, which is a standard shell gas well construction. For the vertical well versus the horizontal well, for the vertical well drills downward, while the horizontal well drilled off a vertical borehole. This shows the surface, upper Brannet, lower Brannet, and the wood fort. Vertical stress, minimum horizontal stress, maximum horizontal stress. For the multi-stage completion design, which is from 1000 to 2000 meter horizontal wells, fracks about every 200 meter, from 100 to 300 tons per frac, and there is 2 primary completion techniques. For the completion objective, which is to create the complex fractures that will feed a main fracture connected to the well bore, and also to minimize the near well bore tortuosity to reduce the chance for screen out. And also to create the conductive path to allow flow of stimulation fluid as well as reservoir fluids. Also for the tortuosity, which is the ratio that characterizes the convoluted pathways of fluid diffusion and electrical conduction through porous media. Tortuosity, which is the ratio that characterizes, which is also in fluid mechanics of the porous medium. Tortuosity is the ratio of the length of a streamline, a flow line, or path between 2 points to the straight line distance between those points. And also for the tortuosity, which is also can be defined as the ratio between the shortest possible pathway and the distance between 2 points on the real pathway of a water molecule. It also reflects the efficiency of the percolation passes, and also which is an important parameter used to correlate the electrode microstructure within the performance through the numerical modeling. For the fracture orientation versus the well placement, fracture orientation, which is a parameter which connects the single fracture to the environment. While the well placement is the process of finding the best location, orientation, and trajectory of a well to maximize the production performance and also the economic value. Also, simulated fracture enlarges the contact area within the reservoir, increasing drainage passes for fluid flow and improving the productivity. So this could fractures influence the reservoir integrity. Also, for the fractured reservoir, which is bulk permeability and the permeability are affected by the presence of the naturally occurring fractures, which are essential for the delivery of commercial petroleum production. We have different types of shale: Interium, Granite, Fetival, New Albany, Ohio, Woodford. For the Interium, which is set from 40 to 80 acre spacing for Interium wells. For the Granite, which is drilled at 40 to 160 acre spacing, and we have some companies testing the wells at 20 acre spacing. For the Fetival shale, which is allows 40 acre spacing, wells must be 560 from unit boundaries and other unconventional wells in the Fetival shale. New Albany shale in 2006 and 2008. In 2006, wells were being drilled on 160 acre spacing. By 2008, wells were being drilled at 80 acre spacing. For the Ohio shale, which is from 40 to 160 acre spacing drilled. For the Woodford, which is too late for 640 acre, Chesapeake Energy is drilling horizontal wells on 160 acre spacing, and several companies like Newfield Exploration and PetroQuest are planning to drill on 80 acre and 40 acre spacing. So those are the different types of the shale plays. Fluid compatibility. Some shale sensitive to fresh water or extreme pH environment. Lab testing recommended for the fluid compatibilities. CST can be also performed quickly. Shale pack tests provide more data but more time intensive. So this also shows the sensitivity of clay control additives within the charcoal sample, which is the brine's concentration versus the CST ratio. For the fractures in shale, are the storage and the permeability space of shale gas, which also compared within the conventional classic rock and carbonate rock reservoir. Shale reservoir have more solid plasticity, fracture genesis, and microfractures. So they are also the fractures dominated by the high deep angle. Vertical fractures and horizontal fractures are mostly slip fracture. Also the types of fractures, which is the stable fracture, oblique fracture, transverse fracture, and the open fracture. So those are the four types of the fractures. For the initial shale stimulation, large volumes of water, 80,000 barrels, small volume of propping agent, high pump rate within low propane concentration, attempt to simulate multiple pref clusters at one time. Other consideration, we have the high viscous gels may create by winged fractures. High initial pressure may be also due to damage near wellbore, so we have the cement mud in fracture, and a small volume of acid can also help to overcome this damage. Microseismic helps in monitoring the stimulation pattern. Hydraulic fracture, pay zone and the shale well, treatment well, observation well. As I said, for the types of the fracture, which is a stable fracture, oblique fracture, transverse fracture, and the open fracture, we have the granite shale and the upper Cretaceous. The granite shale, which is quartz rich, and the upper Cretaceous, which is clay rich. Characteristics of the shale gas: integrations of each source rock, reservoir cap rock, with no trap or no gas water contact, which is also gas extenses in continuous big area, low porosity and low permeability. For the gas shale, which is a form of natural gas found in underground in shale rock, it is also classified as unconventional because it's found in shale, which is less permeable rock formation than sandstone, siltstone, and the limestone. This shows the increasing frequency of frac job in 2004 and 2006, the number of frac jobs per well versus the gas wells. We have the KCl and the Gilling agent, the same percentage, 0.055%. Scale inhibitor, 0.04%. pH agent, 0.01%. Breaker, which is 0.009%. Crosslinker, 0.006%. And the iron control, 0.004%. Corrosion inhibitor, 0.001%. The same as biocide. Acid, which is 0.11%, friction reducer 0.08%, and the surfactant, which is 0.08%. The bigger percentage, which is the water, which is 90.6%. So this shows the complete data collected at a vetival shell, which is the composition of the propane-laden fracture fluid. Technological engineering issues. Okay. For the hydraulic fracture, which is the key to unlocking the potential of shale plays. Also for the hydraulic fracturing, which is a technique used in unconventional gas production. Unconventional reservoir also can cost effectively produce gas only by using the special stimulation technique like the hydraulic fracture or other special recovery process and technology. Hydraulic fracturing, which is a technique of breaking rock for producing new fractures using pressurized fluid brought to the deep formation through wells driven from the Earth's surface. Also, which is a generalized increased orbital contact pressure results in direct compression and fracturing of the thin orbital bone. It's also the method used to extract natural gas and oil from deep rock formation known as shale. In this method, drilling operators force water, sand, and a mix of chemicals into horizontally drilled wells, causing the shale to crack and release natural gas or oil. So also the mechanics of the hydraulic fracture, which takes place when the fluid pressure within the rock exceeds the smallest principal stress plus the tensile strength of the rock. So the air pollution and the water contamination due to the toxic chemicals are causing in hydraulic fracturing. Also, for the hydraulic fracturing, microseismic monitoring suggests that the complex fracture network can be developed in some shale plays. So the value of the microseismic data is that it provides operator with a 3D visualization of where the hydraulic fracture process is impacting the rock into the reservoir. Also for the hydraulic fracturing, which is a technique in which a large volume of water, sand, and small volume of chemical additives are injected into low permeability subsurface formation to increase the oil and natural gas flow. Also for the hydraulic fracturing, microseismic methodologies offer industry the best method to determine the efficiency of the fracture stimulation process as it applies to make contact within the gas resource locked in the rock. So for the real-time monitoring of microseismic events allows operators to optimize the hydraulic stimulation process by modifying the fracture stage design while pumping into the formation. So there is an introduction of horizontal drilling and hydrofracking in shale. For the horizontal drilling and the hydraulic fracturing have made it to extract huge amount of natural gas trapped in the shale reservoir. So here we have the pumper. Truck injects a mix of sand, water, and chemicals into the well. Tanker also trucks deliver water for the fracture process. Recovered water is also stored in open pits, then taken to a treatment plant. Natural gas flows out of the well. Natural gas is tracked to a pipeline for a delivery. So the rig drills down into the gas-bearing rock, which can be 7,000 feet or more below to the surface. The well is lined with an steel pipe. The well is sealed uh, with cement to a depth of 1,000 feet or more, also to prevent fluid or gas from seeping into the groundwater. Using the steerable motor or the other means of the operators, horizontally 1,000 feet or more into the gas-bearing rock. So also the gun charges holes through the well casing and into the surrounding rock. This picture shows the sand and water and chemicals pumped in at high pressure fracture rock. And this picture shows the gas escapes through the fissures propped open by sand particles and up to the surface. According to the geologists, there are more than 688 shale worldwide in 142 basins. At present, only a few dozen of these shale have known production potential. Most of those are shown in North America. Developing shale gas infrastructure will be costly, but today in 32 of the 142 basins, there is some existing infrastructure that could reduce the initial capital expenditure related to the exploitation of shale gas. In the remaining 110 basins with no existing infrastructure, the required investment will be considerable, and this may result in delaying new production coming online or making the entire exploitation uneconomic. Also, for the strategic or other reasons, shale formation may be still worth exploiting. Of course, each shale formation will be evaluated on its own merit. Thank you for your attention.
Sir, the video was off.
Hey, Venkatesh.
Yes.
ഒരു വീഡിയോ ആബ്സെന്റ് ഉണ്ടോ സുരേഷ്?
What?
The video was off.
Yes, I finished the lecture now. There is a
Okay.
question.
Sir,
The difference between the
can you share that PDF in group?
one moment.
Can you share that PDF?
Good day, sir. Can you hear me?
Yes.
The other time you mentioned about hydrofuck operation. Um, Actually, I don't know what's the meaning of hydrofuck.
You mean hydraulic fracturing?
Okay. Hydraulic factory. Thank you,
The
sir.
hydraulic fracturing, which is a method, is used to extract the oil and natural gas in the reservoir. Or it's also a technique of breaking the rock for the producing new fracturing by using the pressurized fluid brought to the deep formation through wells driven from the Earth's surface.
Hydraulic fracturing does not depend any kind of types of the rock can be.
Only the hydraulic fracturing is a technique that's used to extract the oil and natural gas of the reservoir, but it's also used in the completion of tight gas and shale gas wells.
Okay.
Any other questions?
How long hydraulic fracture can be operating?
What?
Sir, which fracturing methods are used in shale formation?
I can't hear the question.
Sir, which type of fracturing methods are used in shale reservoir?
There are many types of fractures in the shale. For example, the natural fractures and the hydraulic fracture. The fractures also can be used as a natural gas storage space and migration of a channel in shale to increase the gas absorption area and the desorption space, increasing natural gas content. Also, for the conventional versus the unconventional, which is the conventional reservoir use the natural energy in the environment to flow of oil and the gas to the surface, while the unconventional reservoir putting energy into the ground for extraction, easier as heat For example, the tar sand or the oil shale, or as a pressure. So this is the main difference between the conventional and the unconventional reservoir.
That is. Go and meet him, boss.
Is there any other questions?
Yeah, sir, like I have one question.
Yes.
Like, how does hydraulic fracturing induce seismic activity, and what geological factors influence this risk? Can you hear me, sir?
Yes.
Yeah, like my question is, how does hydraulic fracturing induce seismic activity, and what geological factors influence this risk?
The hydraulic fracturing causing the felt earthquakes that are extremely rare, and also wastewater produced by wells that where hydraulic fracture can cause induced earthquakes when it's also injected into the deep wastewater wells. And as I said, for the hydraulic fracturing, which is used to extract the shale gas or to extract the oil and the gas in the reservoir.
Okay, sir.
Yes.
Yeah, I have another one question.
Yes,
Yeah,
bro.
like, what are the long-term risks of chemical contamination from hydraulic fracturing fluids on underground water?
Bring down the notification. PC connection.
What are the long time of contamination of what? Sorry.
Like, what are the long-term risks of chemical contamination from hydraulic fracturing fluids on groundwater?
Nah, boss will be a but 100 of our
How long can contamination remains in the groundwater? It can take many months or to many years, which is entered and contaminate groundwater following the normal registry used. So the Thai seeds remains in the soil and the water for many months to many years.
Okay, sir. Okay, sir. Thank you.